Hello, my name is Ismael. Today we will be going over algebra, specifically the law of exponents. Before we cover the specific laws, there's three specific definitions that we have to go over. First definition, a to the n power and multiply it n times. We're multiplying indefinitely until we get to n, or until we have n amount of a's. For example, we have 2 to the second power. It is 2 times 2. Notice how we have our n here is 2. Now on to the second definition. This definition states that any number to the 0 power is equal to 1. 2 to the 0 is equal to 1. Subsequently, 5,280 to the 0 is also equal to 1. Now, the last definition. This definition states any number to the negative exponent power, in this example, negative n power, that would be equal to 1 over a to the n power. 1 to the a minus n, that in turn becomes a to the n power. Now we're moving on to the actual laws. The first law states that if we have a to the n power multiplied by a to the m power, the result would be a to the n plus m power. For example, we have 2 to the second power multiplied by 2 to the third power. This is equal to 2 to the 2 plus 3. If you add the two exponents, the actual result is 2 to the fifth power. This can also be done with a variable. X to the second times x to the third is x to the 2 plus 3, which is equal to x to the fifth. The next law states that if we have a to the n power, and then that in turn is to the m power, the result is a to the n times m power. For example, if we have 2 to the second power, and that is to the third power, our result is 2 to the 2 times 3 power, which in turn gives us 2 to the sixth power. Like in the first law, this could also be applied to variables. If we have x squared to the third power, the result is x to the 2 times third power, which is x to the sixth. The third law states that if we have a number a multiplied by number b, and those two numbers are to the n power, our result can also be written as a to the n times b to the n. For example, we have x times y to the second power. That result is x squared times y squared. If we have x to the third and y to the second, and that is also squared, our result, this now becomes a combination of the third law and the second law. So if we rewrite it, we have x to the 3 times 2 times y to the 2 times 2, meaning that our result is x to the 6 times y to the 4th. The fourth law states that if we have a to the n, and that is divided by a to the m, our result is a to the n minus m power. For example, we have 2 to the second power divided by 2 to the third power. Our result can be written as 2 to the 2 minus 3 power. For example, if we have 2 to the fifth power divided by 2 to the third power, our result can be written as 2 to the 5 minus 3 power. Now this can in turn result into 2 to the second power. Now on to the last law, the fifth law. This law states that if we have a fraction a over b, and that fraction is raised to the n power, then our fraction can be rewritten as a to the n divided by b to the n power. For example, if we have x over y, we raise that to the second power, our result is x to the second power divided by y to the second power. In combination with the third law, if we have x to the third power divided by y to the second power, and that is raised to also the second power, we can use the third law in combination with the fifth law. Here our result would be x to the 3 times 2, and the denominator would become y to the 2 times 2, with our result becoming x to the 6th and y to the 4th. Now that we've discussed all three definitions as well as all 5 laws of the exponents, we will apply these laws in the following example. Now, if we recall from the first definition, which states that a to the n is just a times a times a n number of times, we can then evaluate 2 to the third as well as 3 to the second. This is not necessarily the first step you have to take, it just makes the notation cleaner. Using the first definition, 2 to the third is 2 times 2 times 2, which is just 8, and 3 to the second is 3 times 3, which is just 9. If we rewrite the function that was given to us, it can be rewritten as 8 x to the 4th, y 7 to the squared, divided by 9, x times y to the 3rd times 7, or times z. Now, the next step is we can actually use the third law of exponents. Specifically here in the numerator in yz to the squared. Using the third law, which states that ab to the n power is a times n, or a to the n times b to the n, we can rewrite this equation like this. Y squared, a times x to the 4th, y squared times z squared over 9xy cubed times z. Now we can use the fourth law of the exponents. The fourth law stating that a to the n divided by a to the m is equal to a to the n minus n. Note, this specific law only works if the base of the exponent are equal. For example, here we have x to the 4th in the numerator and x to the 1st in the denominator. Therefore, we can use the fourth law. And same thing for the y's, and also the same thing for the z's. So then we are left with 8 to the x to the 4th minus 1 times y to the 2nd minus 3 times z to the 2nd minus 1. And that's everything's divided by 9. If we rewrite this again, we are left with 8 to the x to the 3rd, y to the negative 1, and z. In the denominator, we have 9. Now, we are not yet done, although it looks like we have simplified as much as possible, because a general rule of thumb is we never want to have any negative exponents in our expression. So this is where we will apply the third definition. That definition stating that a to the negative n is the same thing as 1 over a to the n. If we rewrite this expression using the definition, we are left with 8 times x to the 3rd times z divided by 9 to the y. And that's our simplified expression. Thank you for watching the video. Please don't forget to subscribe to our channel. Don't forget to like us on Facebook, Twitter, and Instagram. If you have any questions or concerns, please leave a comment below or visit us at the Q Lab.